This is the summary created from the video. Lecture 51 Do Computing. The rising energy demand necessitates the adoption of renewable, carbon-free generation sources and efficient DC microgrids, which enable demand response and load optimization during peak and off-peak periods, while also allowing for load management in the absence of grid and integration with smart grids for efficient energy management. The DC microgrid architecture comprises DC loads, generation systems like photovoltaics, and storage systems like batteries and ultracapacitors, with control schemes involving battery, ultracapacitor, grid-side converter, and photovoltaic inner loops, all governed by a comprehensive power flow control strategy that extracts reference currents for the inner control loops and ensures efficient operation in both grid-connected and isolated modes. A simulation of a grid interactive DC microgrid has been implemented in a real-time simulator with components such as a PV module, battery, ultracapacitors, DC link, filter, and utility grid, and carefully chosen control parameters for battery, ultracapacitor, PV, and voltage loop, allowing for the exploration of the power flow control strategy under scenarios like renewable power variation, grid faults, and islanding. During peak hours, the energy management strategy takes into account the PV output versus the load demand and the battery state of charge, while in off-peak hours, the bus voltage is maintained with minor variations, and the ultracapacitor and load currents are regulated. And in isolated mode, the available energy is balanced through smooth control strategies, with the overall system capturing the PV, battery, and ultracapacitor currents and voltages simultaneously while meeting the load demands. The proposed system simplifies power flow control for scenarios with less than 30% renewable energy utilization, optimally utilizing PV and storage systems under grid availability to balance energy needs, with the developed strategies explored under practical conditions to ensure reliable and efficient microgrid operation, and the simulation demonstrating satisfactory performance and grid stability even in extreme conditions. The key takeaways are the rising energy demand necessitating renewable, carbon-free generation, the control schemes for managing DC microgrid loads, generation and storage, the simulation setup exploring renewable power variation and islanding scenarios, the energy management strategies balancing PV output, load demand, and battery state, the strategies for grid-connected and isolated operation modes, and the satisfactory results under practical conditions, ensuring grid stability. Please stay tuned for more summary videos.